Should we go ahead and start?
Yes, we can.
Okay, good evening if you're in Europe or Africa, or good morning if you're in America, and difficult to keep track of all the time zones. Welcome to Dragonfly Aerospace. My name is to our live session called Bringing the Best Imaging Capabilities for Your Mission. That is our goal with Dragonfly Aerospace. So yeah, welcome to our session, and my name is Brian Dean. I'm the CEO. Dragonfly Aerospace started the beginning of 2020, so we're a new company, but we're taking our experience from previous companies in South Africa over many years. Myself personally, I was working with the Space Advisory Company before Dragonfly Aerospace for about 9 years, and before that with Airbus Defence and Space in the UK for about 5 years as well. So yeah, over to that. After that, I'll hand you over to the other panelists, Rikus and Janine, to introduce themselves.
Good evening. As Brian said, yes, I'm Rikus Cronje. I'm the head of our imaging division at Dragonfly Aerospace. I've, as Brian said, added Dragonfly started at the beginning of the year. Before that, I was also with SAC, Space Advisory Company, for about 4 years. And prior to that, I spent 7 years with Carl Zeiss in South Africa in the defense industry, and also run about 7 years with Airbus Defence Systems doing electro-optic imaging. So yes, I think we've got a well-grounded background in imaging, and we'll take it from there.
Hi everyone, my name is Janine Nicholson, and I was also with the Space Advisory Company previously. And prior to that, I spent 18 years with SES on the GEO and MEO side of the house. Maybe just some housekeeping tips. If you have any questions, please put them on the chat line. We'll address them either online, but also in the Q&A session afterwards. And just to note that we're also recording the session for future use. Thank you.
Okay, great. Thanks, Janine and Rikus. Yes, I'm going to take you through a bit of a presentation on the background of our company, some of our what's our story. Let me just get that sharing. Okay. So I'll take you through the vision of our company, how we came up with the name Dragonfly, a summary of the missions we've done before, leading up to now in South Africa and in our company and our previous companies. I'll give you an introduction into our core focus, our facilities here in Technopark Stellenbosch. And then Rikus will take you through our range of electro-optical images, and then we'll have a video and then a Q&A session after that. So in terms of our vision, Dragonfly has a vision to create high-performance imaging satellites and payloads that are designed for compact satellites that enable large constellations. You know, in order for us to launch large constellations, they need to be small and light. We are approaching that from two angles. One of that's in the CubeSat world with our CubeSat images, and the other side is making compact microsatellites that really punch above their weight with performance in a small package. And we believe this will lead to the ability to have persistent views of the Earth in a wide range of spectrums. You know, we're focusing a lot on spectral bands and hyperspectral and things like that, as well as even radar. And this kind of information, provides unprecedented business intelligence, which allows us to understand the way the world is working, how the markets are working, which in the end helps companies and countries to develop better and improves the lives of people around the world. So why Dragonfly? Well, Dragonfly, we were looking for a name for our company. We started at the beginning of this year, and we had an interim brand called Southern Space, which we used for a few months while we were preparing for launching our long-term brand. The long-term brand, we wanted to come up with a concept that tied in with what we do. And we looked to the animal kingdom. You've probably seen from our products that we like looking to the animal kingdom. And we decided, what member of the animal kingdom has the best eyesight, and we looked at it from that point of view, and we came across repeatedly in multiple references that the dragonfly is one of the best eyesights in the world. And then when we started looking at it more closely, we saw that it's also this fantastic flying machine. It has fantastic stability and agility, can fly in 6 different directions. And this is a great analogy for a high performance imaging satellite. The stability and agility is really important there. And then the dragonfly in particular, of the insects, has really big eyes that actually provided with close to 360 degrees of vision, and the individual facets of the compound eye build up the bigger picture. Now, we thought this was a great analogy for a constellation of satellites, because each one of those satellites is building up a piece of the picture, and together you get a total view of the globe, 360 degrees around the globe. So that was the idea around the concept, and obviously we wanted something that would be distinctive and set us out among the rest of the market. And we're very happy with that brand, and very proud to launch it. And the feedback that we've had so far has been really great. So thank you very much for that. In terms of South Africa, and there's a long history in building space products, space missions, primarily electro-optical imaging missions. And this in fact started in the 1980s. There was a national program in South Africa. This program never ended up launching a satellite, but it built up a lot of skills in the country. And some of that expertise that was developed during that period resulted in the starting of a satellite at Stellenbosch University in the Electronic System Lab, ESL. This satellite was called Sunsat, and it was built almost entirely by students and from scratch. So every bit of metal and every circuit board on that satellite was designed and built by South Africans. A few exceptions, obviously, but the bulk of it was built here in Stellenbosch, and it's launched in 1999. Had a 12-meter resolution camera on it, and it was really compact for the time, 64 kilograms. Was already a signal of things to come in the future, where the satellites aimed at being compact and small, and obviously that's gone to the extreme now with nanosatellites, CubeSats. But that satellite was very successful, and in fact has been subsequently regarded as the best microsatellite imaging solution at the time. So that's of the the 20th century. So that's a real credit to the team that built it, and some of the people in that team are still with our company today. So that started the story in South Africa, and this led on to other companies. Sunspace was a company that was spun out of University of Stellenbosch. They took an international order for a satellite, as well as an order from the South African government. And that order from the South African government was launched in 2009. It was called the Simbandila Sat. That satellite was around 80 kilograms, and had a good camera on board. But the main job of that satellite was to build a new set of avionics, a new set of electronics, a new architecture, that built on all the lessons learned on the previous 2 satellites. And that architecture that was developed and tested on orbit in Sambalila-sat, has gone on to be used in multiple satellites subsequently with international customers. So around 2009, 2010, Sunspace ran into a bit of financial troubles, and 2 new companies were born out of that. One was Space Commercial Services, SCS, and another one was a division of the NEL, which is parastatal in South Africa, a government company, and the division was called the NEL Space Tech. And these 2 companies grew out of Sunspace in around 2010. And the NEL Space Tech ended up focusing very much on national work, working for the national government, while Space Commercial Service focused its energies internationally, building up relationships with a number of international institutions and companies, and operate, many successful missions were launched, and a lot of this was on the basis of consulting work that was done internationally. And then in around 2014, 2015, the Space Commercial Services started focusing on building products to sell on the market as opposed to consulting services. And the first product that was developed was the Gecko camera, which was launched on a 2U technology demonstration CubeSat in 2017 called InSight 1. InSight 1 was a part of the QB50 constellation for the European Union, and was a very successful member of that constellation, but and carried a primary payload as part of that mission. But as a secondary payload, it carried the Gecko camera, which was a flight demonstration for that camera, and had great results. So this camera was designed from the outset to we were thinking far ahead when we designed this camera. So the goal right from the beginning was to build hyperspectral cameras. The electronics right from the outset was designed with very high data throughput needed for hyperspectral imaging. And although the Gecko camera was a snapshot imager, it provided a flight test of that hardware that is now used in the rest of the range of cameras. So that was the first mission. It was very successful. That mission lasted for close to 3 years. It was launched from the International Space Station, so our days were numbered. We were going to re-enter sooner or later, but fortunately managed to stay up for close to 3 years and re-entered a few months ago. It was a great success. The Gecko camera took some fantastic pictures. You've hopefully seen some of them on the internet, and in fact took an image a few days before re-entering, and it was really exciting because as we were downloading the last frames of the image, we were watching the telemetry and we could actually see the temperatures rising as we were re-entering the atmosphere. So that was pretty cool to see. That same electronic space that was then proven on this 3-year mission with InSight 1 was used in subsequent camera products and payload products as well. The first one after that was the Paktiz 1A imager for SEPACO, which is the Pakistan Space Agency, and this was part of their technology evaluation satellite. SEPACO built the bus, and Space Advisory Company, which is a subsidiary of Space Commercial Services, provided the payload. And this was a very successful, was and is a very successful mission. It's that imager at a 500-kilometer altitude provides a 2-meter resolution and a 30-kilometer swap with pan, red, green, and blue multispectral line scan imaging bands. Now that mission has gone very successfully, and I know that the SAPARCO has done a lot of remote sensing work with the satellites and feeding it into their image processing division, which buys imagery from throughout the world. And the results of this camera were really great when referenced with international competitors as well. Because we designed this payload electronics architecture from the outset to be able to handle high data throughputs, it's naturally a good use for any kind of payload. So we were then approached around 2017, 2018 to to use the same electronics from the cameras to be a payload controller for a radio astronomy payload. This was for the Netherlands, China low frequency explorer mission. This was a mission that IAC Space in the Netherlands did together with Radboud University, Radboud Lab, and the Chinese Space Agency. And this mission launched on the Chinese orbiter to the moon. The primary role of this orbiter, of the satellite, was to provide a communications relay for the U-22 rover, the Chinese lunar rover. And then as a secondary payload, it had a radio astronomy payload, NCLE, which was to do radio science from the other side of the moon. The U-22 rover is on the far side of the moon, and it needs a communication relay. So the communication relay is sitting in a halo orbit around the Earth-Moon Lagrange point on the far side of the moon. This provides a great spot to do relay comms for the rover on the surface on the far side, and also a great spot for radio silence, with the moon blocking a lot of the Earth's noise in terms of radio frequency noise. So that instrument is still operating. It's getting its first data. It's unfortunately taking a back seat to the primary mission, which is still operational with the U-22 rover, but we're hoping to see great data come out of that mission, and certainly very proud to be part of a mission that's gone to the moon. The success of the InSight-1 program and the Gecko-1 imager meant that there was quite a lot of interest in the Gecko camera, and we've delivered a number of these cameras to companies and institutions around the world. 4 of these have flown already, and many engineering models have been delivered, and a few flight models have been delivered that are still yet to launch. So it's been really great to see the success of the first mission, InSight-1, lead on to this great uptake of this product on the market. The most recent launches was Dushipat-3 at the end of 2019, end of last year, for the Israeli project, as well as a few months ago the Napa-1 satellite for the Royal Thai Air Force. In both of those cases, we were working with IAC Space in the Netherlands, and looking forward to seeing great pictures coming down from those satellites also. So that leads us to the end of 2019 and the transition into Dragonfly Aerospace. Dragonfly was formed by a number of members of the Space Advisory Company team. At the end of 2019, Space Advisory Company was running into financial difficulties and needed to close its doors. A bunch of us were pretty keen to continue the journey that was started in 1993. So we decided to pull together a new company called Dragonfly Aerospace. We pulled many of the senior engineers from Space Advisory Company in, as well as engineers from other companies like Denel Space Tech, to pull together a really great team. We're somewhere in the mid-30s at the moment in terms of numbers, and we're hiring the whole time, so we're growing really nicely at the moment. We've managed to do a deal with an international investor to build the company and invest in the company and grow on our ambitions. You know, we were able to convince this investor that, you know, the heritage and the technology and the skills in South Africa really is valuable on the international markets. You know, we are now investing in that business to build a great international company with certainly ambitious plans going forward. In terms of 2020, the missions that we're working on at the moment, we're very lucky to, as a startup right out of the blocks, deliver a couple of projects already this year. We've delivered a hyperspectral chameleon imager. We've delivered a pair of gecko snapshot images, the RGB snapshot version of the imager, as well as a project for a multispectral line scan imager. In this case, the line scan imager is being hosted on a microsatellite. So we built a custom enclosure for that customer, these projects are pretty much complete and delivered already. In terms of new announcements, we announced at this conference that we've signed a deal with EOS Data Analytics in the US to provide 2 of our HR250 images. This is a 1.4 meter resolution imager with a 20 kilometer swath. And when we pair 2 of those together, we get a really great wide swath imager for, in the case of this customer, their agricultural remote sensing application. And we're very excited to be building these images for them. So that's the story of how we got through the last years until today. In terms of our focus, we're very much focused on electro-optical payloads at the moment. We're investing in manufacturing facilities and environmental testing facilities for achieving those goals of delivering those payloads. As a long-term aspiration, we're looking at synthetic aperture radar payloads as well. You know, very much our thoughts is along imaging systems, and you know, radar and electro-optical are great complementary imaging systems, and we are developing in both areas. In the case of synthetic aperture radar payloads, we have some great partners that we're working with, and hopefully we'll be able to share some more details on these products in the next few months. In terms of imaging satellites, we have obviously a strong heritage in building imaging satellites, with many satellites built by the team over the years. And you know, in the long term, we'll be looking to work with our customers on imaging satellites as well. But in the short term, our focus is very clearly on electro-optical payloads, and you know, we really welcome chatting to partners about how we can build you know, really great imaging satellites together, where we provide the payload and our partners provide the bus. With the experience of what we've done in the past, we obviously have quite a bit of experience doing launch and commissioning services for satellites, as well as in-orbit calibration and validation. These are important parts of delivering a good performing imaging system on orbit. In terms of facilities, we've taken a lease on a great facility in Technopark Stellenbosch. It is located right at the top of the hill, overlooking vineyards and mountains. So it's really pretty site. It's really great to be situated here. And you know, it's a technology hub of the Western Cape, South Africa, as well as even many space companies located here. And there's a lot of interaction that we have with other space companies in the Stellenbosch region. And the building that we're in was actually the building where the space program started in the 1980s in South Africa. So we're really proud of the history that we're continuing here with Dragonfly Aerospace. This building's big, nice 300 square meters building with offices and about 1,000 square meters of clean room areas, which you know is really good for building our payloads and later satellites. We've got environmental test labs, development labs. We've got an on-site power supply, backup generator power supply to power us through any eventuality. So you know, it's a really great facility for for building our aspirations and our dreams. In terms of the clean rooms, we've got some large general clean rooms sitting at ISO 8 standard. One of these is behind me. This is one of our large clean rooms behind me here. I don't know if you can see, it's a bit dark. It's getting into the evening here in South Africa. As well as some clean rooms dedicated to building our images, as well as within those imager clean rooms, we have ISO 6 flow cabinets, which is really important for building the delicate parts of the payloads, like the focal plane assembly. Okay, Rikus, over to you. Let's chat through these payloads.
Good evening. As Brian said, yes, we've got a whole lineup of small images. If you look at the slide on there, we've got the Gecko on the left-hand side, which is our small entry-level imager. It's specifically aimed at CubeSat satellites. It fits into the standard CubeSat PC104 type form factor. It's aimed for companies that want to start off in space, or universities or education programs or training programs. The next one is the Mantis imager. That is very much based on the technology from the Gecko. It's the same form factor. It just uses the same electronics. The telescope is a larger, longer focal length unit, providing a 16-meter GSD. The telescope in that case has been designed to offer a snapshot mode, multispectral, and can also be used as a hyperspectral imager. And I'll just now discuss, when we look at the specific specifications of each of the images, as what can exactly be achieved with the hyperspectral unit. The Chameleon is the larger brother of the Mantis. It's got a longer focal length, providing a 10-meter GSD. And what we try to do is to use the same building blocks that has heritage and that we use on all of these units. In other words, we follow a very modular system. The electronics are the same. It's got the same electrical interfaces, the same data interfaces. So it's very easy to upgrade from one of the cameras. In other words, if a customer has invested in one of the smaller cameras and has already proven hardware that interfaces to the cameras, to move on to one of the larger images in the sort of what you call the CubeSat type sizes, it's very a modular system. You can upgrade easily to larger images. The same applies for the Cayman. And then the last two images are the HR250, which Brian has discussed, for which we've now got a contract to deliver 2 of these, and the Raptor, which is the flagship of our imager range currently, which is a sub 1 meter resolution imager. And if you look at the detailed data sheets, in the 2 small cameras are listed. As I mentioned, the Gecko, it provides a 39-meter GSD and 80-kilometer swath from a 500-kilometer reference orbit. It's perfectly suited for a 1U form factor. In other words, if you've got it fits well into a 2U satellite. There's enough space for avionics and the rest of the system for additional science missions. The unit is fitted with a control unit that's got 128 gigabytes of onboard memory. It's got standard control interfaces, SPI, I2C CAN, RS422. You have a choice of 8-bit or 10-bit data, and as mentioned, we offer this unit primarily in an RGB system, but we have built versions that is line scan. In other words, we run a multispectral line scan architecture on the Gecko. If you move over to the Mantis, as I discussed, it's just the larger telescope that is specifically designed for a broad spectral band, and we use radiation-hardened technologies to sort of safeguard a telescope against radiation levels. The unit is again exactly compatible with the Gecko in terms of form factors. So the idea there is that if an institute or a company started off with a Gecko system to prove a satellite bus, you can move over to the Mantis. It's effectively a drop-in replacement for the Gecko. The interface is the same, the mechanical volume is the same, but it will provide a 16-meter native resolution. In a snapshot mode, in a multispectral mode, it will be pan 16 meters, and we bin the multispectral data 2 by 2. Currently, we offer 5 spectral bands on the MS side. So we've got a library of available spectral bands that we can select bands from to build up a filter stack for operating on the MS side. If you look at the hyperspectral system, it will provide a 32-meter GSD, or depending on the signal to noise required, we will sometimes bin that up to 4x4 to provide a 64-meter GSD. We have on the hyperspectral side what we would like to call a software-defined imager. For people familiar with the radio world, there is a thing called the SDR, which is a software-defined radio where you can program your hardware for selective radio frequencies. We've got a similar technology where we can provide a selection of around about 148 to 150 spectral bands, and software. From a software perspective, you can then select how you want to configure those bands to provide multispectral bands that are capable of this matched to classical satellites like the WorldView 2 or Spot of one of the other ones. So you can, from mission to mission or orbit to orbit, you can reconfigure the imager to cover various spectral bands to suit specific needs. Again, it uses the same electronic technology that's got flight heritage and flight proven, the 128 gigabytes of onboard storage. And then in the hyperspectral, multispectral case, we would suggest that the LVDS data interface is used because of the large volumes of data. If we look at the next slide. In this case, we have the Chameleon and the Cayman. Both of these are based on sort of heritage telescope designs that's been proven. It's a Matsukov design. In all cases, we use radiation tolerant materials for the telescopes. In the Chameleon case, we have a native resolution of 10 meters for pan, and then again we've been up to 2x2 for multispectral. In this case, we can offer up to 7 spectral bands on the multispectral units. In the case of hyperspectral system, we use a different detector, and then the system has got a 10-meter native resolution, but bin to either 2x2 or 4x4. In that case, it provides a swath of 20 kilometers. System is a bit larger. It will fill a 2U volume, so it's ideally suited for very compact 3U satellites or ideally a 6U unit. Again, fitted with the same electronics as discussed previously, 128 gigabytes of onboard storage and the standard interfaces that we offer. The Cayman is, again, a larger telescope providing a 5-meter pan resolution, again, with a choice of up to several multispectral bands that we bin 2x2 to provide a 10-meter resolution. In this case, the GSD from a reference orbit of 500 kilometers will be 20 kilometers. A little bit of a bigger system, so ideally suited to a 6U satellite or even used in a microsatellite. And if you look at the last of the line of large images, here we have the HR250 and the Raptor. Again, we follow our very modular philosophy. The electronic back ends of those two images are the same, using the same readout electronics, same detectors, and we again have the more standard, industry standard data interfaces. We provide LVDS for data download. The command and control to the images are CAN bus or RS422. These units, the HR250 has got a native pan resolution of 1.4 meter GSD, and the multispectral will be binned to provide a GSD of 2.8 meters. In this case, again, it's offered with up to 7 multispectral bands that can be chosen by the customer from a standard list that we've got. We also provide the capability of customizing spectral bands specifically suited to customer needs, and it will add that to the detector units. The Raptor, as I mentioned, is the same philosophy. In this case, it's a larger, significantly larger telescope, and it will give you a sub-meter resolution. The pan is 0.7 meters. In this case, we bin 4x4 to achieve the required SNR levels for multispectral bands. So the GSD in the multispectral will be 2.8 meters. The Raptor is a fairly large telescope, so it's aimed at microsatellites in the 100 to 150 kilogram range, whereas the HR250 can be fitted to smaller satellites, typically 50 to 100 kilogram bus. Again, as mentioned, LVDS data interfaces, and in this case, we offer 512 gigabytes of storage in both of these cases. Thank you.
Okay, great. Thanks, Rikus. Okay, so I'm going to show a video now. We pre-recorded a video as part of the IAC conference for it is available on our booth and is distributed through the IAC channels. It gives a good background on the company and some footage of our engineers at work. So hopefully it is informative. I will just add it now and just share it, and then we will get going. Okay, let's see.
Hi, my name is Brian Dean. I'm the CEO of Dragonfly Aerospace. We're a new space company in South Africa, building on a proud history of space projects in the area of electro-optical imaging. Dragonfly, we combine the knowledge and lessons learned over the last 40 years with the latest technology in terms of materials and electronics to create imager products that, when combined with a modern satellite platform, can create a compact, high-performance imaging solution. These compact solutions allow our customers to build constellation systems with sub-meter imaging, daily revisit times, and customizable spectral information for only a fraction of the cost of what has been achievable up until now. We believe this technology and price point will lead to a new way of thinking about what is possible for remote sensing. Though we are a fresh face, we are already working with some great partners, taking advantage of the technology and experience gained on our previous projects. Our experience in building imaging satellites means we understand the full system engineering design challenge behind building an operational imaging system. And we apply that knowledge to make our images robust to the constraints of the satellite bus and the needs of our partners. We're currently looking to build on this momentum and team up with market leaders and innovative partners to create exciting new solutions. We are even collaborating with some of our competitors to build products that take advantage of the strengths and novel ideas of each partner. Our team has a broad experience in understanding the end user's needs and helping them to choose the right technology for their application, which will ultimately fulfill a need right here on Earth. For end users working on their first system, this can be particularly useful. We're working to explore beyond Earth with our images taking pictures of the moon and soon to be heading off to the asteroids. We are excited to announce that we'll be delivering 2 of our HR250 images to EOS Data Analytics for their upcoming mission targeted at agricultural monitoring. The 2 images we provide will be used side by side to create a wide swath imaging solution with 7 spectral bands at close to 1 meter resolution. We're looking forward to announcing a few other big deals that we're working on at the moment in the next weeks. I'm really proud of the team that we've gathered in Dragonfly Aerospace. We have attracted some of the most talented engineers and managers in the space industry.
I'm Rikus Cronje. I'm the head of electro-optical system engineering at Dragonfly Aerospace, where we focus on building imagers for satellite missions. These range typically from our Gecko imager, which is a small imager for CubeSats, aimed at universities and small companies that want to enter the space market, right through the Mantis and Chameleon range up to Raptor, which is currently our large imager that we're proposing for the market, which is a 400mm system that will give a sub 1 meter resolution.
Hi, my name is Nicky Steenkamp. I'm an electronic engineer working at Dragonfly Aerospace. I'm the team leader for the electronic engineering team within the company. I've been in the industry, in the South African space industry, for close on 20 years. I've worked on many different subsystems. Many of them have been cameras.
Over the years, members of our team have worked with space agencies like ESA and NASA, industry leaders like Airbus and Thales Alenia, as well as universities and SMEs and startups. This broad range of experience has pushed us to adapt to the needs of each kind of customer and to find the root of what is important to them. We have made our home in a unique design and manufacturing facility at the top of Technopark Stellenbosch, where the South African space industry began. This facility is ready for us to perform right now and has space for us to grow with our ambitions. Our portfolio of Imager products covers a wide range of satellite platforms, starting with 1U CubeSats and leading up to a few 100-kilogram microsatellites. We're looking forward to being a part of your future missions. Contact us to explore the path of working together.
Okay, great. So I'll give a little bit of a summary of our approach to business, and then we are going to go into the Q&A session. In terms of our business, we're very keen to partner with companies and market leaders from around the world. We really believe that the way to approach the space industry is to look at what the end user's needs are and to build a compelling solution to address that need. And in order to do that, we need to build strong teams with collaborating with other partners. This can be at a satellite bus level, it can be at a ground station network, data download point of view, and with image processing partners. So in the end, we are producing data that is either analytics ready for our customers, or even producing analytics for our customers. So this, I don't know who's all in the session today, but if you are a customer for a camera, we welcome welcome you to contact us to find out more information about our images. If you're an end user, welcome you to contact us to chat about how we can come up with a unique solution to address your particular need. And if you're a competitor or partner, a potential partner, we welcome you to contact us and find out more about how we can collaborate on making really great solutions for the end user. We've got, it's now, I guess, almost the end of the IAC, but we've had a booth through this conference where you can download our brochures. You can find out some more information about our products and chat to our salespeople. And I don't know how much longer that's going to operate, but please take advantage of that. We're really proud to be part of this interesting COVID 2020 cyberspace conference. It's been an experiment for us. We've never taken part in a virtual conference before. Hopefully this live session has been informative. We will have this question and answer now to address any other of your questions. And we certainly welcome chatting to you after this conference as well. Okay, so Janine, let's go over to the question and answer session.
Okay, so Rikus has addressed most of them already. So the first question, I don't know if you want to go through it, Rikus, was whether we do standard images. Okay.
Yes, I'll go through quickly. There was a question that asked, do you supply only standard imagery, or are you capable to work on sophisticated solutions needed by a customer? We've got a standard line of images that we use, but as I mentioned previously, we follow a very, very modular approach, and many of the satellites that we've done in the past have had very specific customer requirements. So yes, we can either start a complete design from scratch, for lack of a better word, for a customer, or we can customize our existing designs to suit specific needs, as we've done with one or two of the images we've delivered this year. Then there was a question of, does the HR250 have flight heritage? In the HR250 case, the telescope is new, but it is based on a well-known, call it optical principles, and the design techniques that we have employed on the HR250 are based on our heritage techniques that we've developed. And the electronics, again, is also based on existing flight-proven technology that we have in-house in the company. There's another question. Are you now applying R&D efforts aimed at increasing your image tech properties? Yes, that is something that any company that is serious about the future needs to do. So although we are very busy working on customer images and requirements, there is a continuous drive inside the company to always better our images and start looking at new technologies and try to be at the edge of the market in our specific niche market that we're operating in. Then there's a question, we are newcomers in the space business. Would you be able to provide consultancy training service to a company like ours? Yes, as Brian mentioned, we came from the SES company, specifically SAC, and SAC's acronym was a Space Advisory Company. In that specific instance, a lot of what we did was aimed at advising customers, providing consultancy services, and during that period we've completed numerous training programs where we guided companies and institutions into space, what do you call it, space design capabilities, training the engineers. So yes, I think we're quite good at exactly that specific market. And then there was a last question, how many images can be done simultaneously at your facility? That's a bit of a difficult question, so it depends on what is exactly termed simultaneously. Our thermal vacuum facilities can probably test more than one small image at a time, but on the larger images that you can only run one large imager through the test facility at a time. But the production facilities, test facilities that we do have is very easily capable of simultaneously running about 4 images at any given point of time that we can have in that facility. Okay, so I don't know if there's any other. Oh, so I think there's 2 more new questions. Brian, I think this one is probably for you. It's asked, are you limited to cooperate with any countries?
Well, we're really lucky in being based in South Africa. South Africa is pretty much friends with the world, and we've had business dealings at a company level, at a country level, with almost every country in the world. At a company level and at a country level, we're not really restricted by any restrictions for working with any countries. We do tend to look at the international lists of countries that are not really so easy to work with, and we will have to certainly consider anybody who is on that list carefully if we were to do work with them. But that's not really a government restriction or South African restriction or company restriction. It's just a sensible business practice in that case. Yeah, Rikus, you want to do the other ones?
Yeah, there's one that asks, what is your timeline for developing images suitable for deep space? That will depend on exactly what the requirements are. If it is based on some of the images that we've got in stock, our images have been tested to fairly high levels of radiation tolerance. All the optical materials that we employ are radiation tolerant. So from that point of view, we've already covered quite a bit of the deep space requirements. We've got specific ways of treating high energy radiation single event upsets. And then also from a thermal point of view, it will depend on what the spacecraft has to offer. There are different ways of dealing with the cold of outer space, deep space, if you want to call it that. So we can provide enclosures that go around the camera. We can provide a more cozy environment for the images in that case, and also to provide a little bit more shielding for thermal radiation and so on. So yes, I think it will depend on exactly what is required, but to complete full testing, in this case, it's probably an estimate, if it's not a significant deviation from any of our existing telescopes, doing a full deep space imager development, probably going to run in about, I'd say, Brian, maybe you can correct me, but probably from the range of 8 to 9 months, including significant testing on the unit.
Yeah, look, I mean, in terms of, as Rikus was saying, for radiation, we've tested our electronics to 30K rad, it's a total ionizing dose. And in terms of materials, we certainly looking at glass materials that can withstand that same level of radiation without any major degradation in terms of spectral performance. In terms of development times for a custom imager, as Rick has said, probably 9 months for a custom imager. For some of our, if that's a small nanosat imager, in terms of our delivery times for our smaller images, if it's a standard gecko, we can probably deliver it in 3 months. And some of the other ones, similar complexity, we can deliver in a similar time frame. So I'd say between 3 months for a standard gecko, 9 months for a more custom system, and in the CubeSat range. And then in the larger cameras, obviously a bit longer time, probably more like 18 months to 24 months for a custom large system.
I think then there's the last question that's not been answered so far. It is, what makes you different from your competitors? Will you answer that or me? I think from a technical point of view, we try to be very innovative. We aim at using more commercial technologies to make access to space easier and less expensive. So we don't really use from an electronics point of view, we don't use commercial electronics. We try to make use of the very large selection of automotive or industrial components that's available these days. So we will specifically design around components that we have that has heritage from that list. If it doesn't have heritage, we've got fairly comprehensive test methodologies that we use to test industrial components. So that already brings the price bracket down and enables a little bit more components to be used in designing these systems. And then also we try to be creative in our solutions and really try to understand what the customers' needs are. And yeah, I think we've got a very good interaction with our customers, which is sometimes lacking in of the very large corporations.
Yeah, as Rikus was mentioning, in terms of using new technologies, we actually have a facility based in Stellenbosch where we can do total ionizing dose radiation testing. So it's quite simple for us to take the latest components in terms of what's available on the market in the industrial range and automotive range, and put them through a radiation test campaign to confirm that they can handle the total dose. Obviously, we understand the system events upsets part as well, and we design our circuitry to make sure that we're tolerant to any single event upsets. So yeah, I think there are other people out there using commercial electronics, obviously, and certainly that's something that's come from the CubeSat domain. But we've approached our design methodology has really been about taking our heritage knowledge from microsatellites and applying it to a CubeSat domain or a small microsat domain, as opposed to using the CubeSat methodology and building upwards. We're trying to take the best technology of microsatellites and squeeze it into small form factors. So this is a novel approach, not a novel approach, but it's certainly a good approach. We are also, we're quite unique in the level of experience that we have in South Africa and in our team in particular. In terms of our competitors, either our competitors are large companies with our level of experience, or they are small companies or startups with less experience. So that really helps us a lot in applying the lessons that we've learned over many satellites and many images already delivered until today. We're also making some innovative developments around working with our partners. As Rick has said, our investment in hyperspectral imaging and our ability to actually make let's say a customizable multispectral imager. This is I think a great approach for making these small nanosatellites as high performance as possible. And as we get into this kind of imaging, then the data goes up, and key part of that is getting that data down to the ground. And we're working with telecommunications partners to make sure that we can get the data easily out of the camera and directly to the data transmitter and directly to ground, which is particularly important in a CubeSat, where traditionally the data rates have not been so high from those systems. So this is an area which we're working, and we hope to announce some new developments in that area soon. And as Rick has said, in terms of materials, we are building our optics from the best materials that we can get, and producing what we believe is really good quality products. Is there anything else, or should we wrap up there?
That's all the questions listed, unless there's others that somebody wants to ask.
Are there any other questions from the floor? No, doesn't seem that.
Okay, well, thank you very much for joining us. It's been great to be a part of IAC. We were very proud to be a sponsor of this conference, and I hope these sessions that we have hosted have been informative. I hope if you've had a chance to visit our booth and look at our product data sheets there, and hopefully chat to our sales team. Feel free to contact us after the conference as well. I'm going to put our contact details up on the screen now. We'll leave that to end, and if I can get this thing to work. Always a challenge with this online stuff. Feel free to contact us to find out more, and particularly to chat about ideas about working together. We have had great sessions with a number of partners in the last weeks, brainstorming around what's possible and thinking out of the box in terms of coming up with solutions where we work together and work on the strength of each company that we work with. So we certainly welcome any communication with partners, customers for cameras, and end users looking for a complete solution. Okay, so I'm going to share the screen again now, which has got all our contact details on it. Please go ahead and contact us. Thank you for attending.
Thank you very much, everybody.
Thank you. Have a great day. Okay, and I'm going to terminate the session now. Thank you and goodbye.